Okay, so we've done the power rule, we've done the product rule. Okay, we just finished the quotient rule. Now we're going to be doing what's called the chain rule. Now the reason you need the chain rule would be is if you were given an example like this, where it was say y equals 2x plus 3 to the 7. Now there's kind of two functions going on here. There's a expression inside of an expression. So the way you do that is you first deal with the outside of the brackets, which would give me 7 times 2x plus 3 to the 6. Okay, does everyone see how I got that? Then you deal with the inside and do the derivative of the inside of the function, which would be 2. So your final answer would be y prime would be 14 times 2x plus 3 to the 6. Okay, so I took the derivative of the outside, right? 7 comes down, and then the derivative of the inside is 2. These aren't bad. I don't mind these at all. The quotient rule I find is the most like, right? After the quotient rule, everything's easy. No, you have to work with it, but getting it, it's no big deal. Okay, let's just do one more so you can kind of see what's going on before I do all the notes on it. So here's an example. Y equals, let's do 2x to the 1/2. Okay, if you did the derivative of this, first do the outside, which would be 1/2 times 2x to the negative 1/2. See, I do not change the inside. I just do derivative of the outside, then multiply it by the derivative of the inside, which would be 2. So y prime would equal 2x to the negative 1/2. So y prime would equal 1 over root 2x. Okay, so that's what we're doing today. I thought instead of doing all the notes first and then doing an example, sometimes it's easier to see the example first and then the notes make more sense. Because this stuff can get all confusing with all the f prime, g primes, all these sort of things. So you can see that this is like a function inside of a function. Okay, that's what f of g of x is. And we've done those, right? You've done them in pre-calc. So that's like doing f prime of gx. So do the outside and then multiply it by g prime x. Okay, so do the derivative of the outside function times the derivative of the inside function. You work from the outside in. Okay, so it's the derivative of the outside function times the derivative of the inside function. Okay, now in the Leibniz notation, there's not supposed to be a t here. Okay, so get rid of that. He likes to use u. Okay, so he says, well, make gx, make it equal u. So basically it's like y equals f u. He probably didn't get it when he was making it. Okay, so Now, the notation is dy over du. So you take the derivative with respect to u and then du over dx. Now you'll notice that even if you were doing canceling, these would cancel, which equals dy over dx. So obviously dy over dx equals dy over dx. So what it's saying, it's do the derivative of the outside and then the derivative of the inside. So, and I'll show you how that works when we start moving on here. Okay? So specifically, we apply the chain rule to power functions. So if y equals u to the n and u equals g of x, what you have to do is you have to go, so here's our function, u to the n would be n u to the n minus 1 times du over dx. So you do the derivative of the outside and then do the derivative of u. So derivative of the outside function times the derivative of the inside function. Okay? So that's just a bunch of ways to say the same thing. And I think this makes totally no sense until you actually see the examples. So that's why I kind of did that first. So you can see how this works. Okay? Now, I'm going to just go do it quite slow with all the right kind of things put in, and then as you get better and better, you don't have to write dy over dx. But so this means y prime equals 3 times x squared plus 2, and put a squared up there. Remember, you're doing the derivative of the outside, and then it's times dy over, or sorry, d over dx of x squared plus 2. So I'm doing this in 2 steps to show you that first of all, do the outside times yet the derivative of the inside. I haven't done the derivative, that's why I wrote d over dx. So then y prime would equal 3 times x squared plus 2 squared times the derivative would be 2x. Therefore, y prime, all you have to do is get everything together. You've got 3 times 2x, that equals 6x times x squared plus 2 squared. Okay, so this step here, I don't do this step usually. I just go right to this. Okay, so if you counted this as step 1, 2, or 3, I don't really do step 1. I just do step 2, and you just work right. And sometimes you can get a function within a function within a function, and then just do the one inside of that yet. Okay, and we'll see when you. Okay, so this one here, I think the best thing to do is to kind of get it into exponential form. That's x plus x to a half all to the 1/2. Now this doesn't look like it's much more work than the one above, but because of the fact, you'll see when you get a negative a half, you really have to do some work to try and make this thing be finished. So this is a much more complex question. So how would I do this one? Well, I'm going to do y prime equals. Let's do the outside, which would be 1/2 x plus x to the 1/2 to the negative half. See, I do not change the inside. Times, now I'm doing the derivative of the inside, which would be 1 plus 1/2 x to the negative a half. Okay, so if I was to write this, do you see all of this right here? Because it's to the exponent negative a half, it really should go underneath. So, and then the 1/2 you could just write as 1 like this. Okay, and then I'm going to have 1 plus 1/2 x to the negative half all over x plus 1/2. Oops, x to the half. Okay, so what I circled, I just put underneath. Okay. Now, the next thing we want to do is, what did I do in multi? Yeah. So this 1 doesn't really make a difference up here, right? So you can actually get rid of the brackets. So I'm just going to rewrite that as 1 plus 1/2 root x just a minute here. Yep, root x. Oh yeah, over root x, sorry. 1 over 2 root x. And that's going to be over 2, and this is going to be root x plus root x. Okay, all I did was get rid of the Okay, everyone with me so far? I just got rid of the exponents and turned it into radical signs. Now, you can't have a fraction in a fraction, and up top we still have 1 over 2 root x. So I'm going to have to find a common denominator. So this is going to equal 2, or root 2, sorry, 2 root x over 2 root x plus 1 over 2 root x. And that's all over 2. That's just a mean example. Okay. So this would equal 2 root x plus 1 all over 2 root x all over 2 root x plus root x. Okay, so what I'm going to do is I'm going to take that division statement and make it into a multiplication statement. So this would be, I'm going to start over here a bit more, 2 root x plus 1 over 2 root x. And then I'm going to go times 1 over 2 root x. Oops, root x. So I took division and turned it into multiplication by reciprocal. Okay, so this would be 2 root x plus 1 all over 2 times 2 is 4 root x times x plus. Looks easy now, hey? So 2 root x times 2 is 4 root x, and then this was just stayed here. A lot of root x's. Yeah, just multiply it across. Hmm? Well, I kind of factored it out too. You know what? You could keep going with this forever, actually. It's kind of more, I just did it in case it's a multiple choice question. Could you get there? And it's just always nice to keep practicing all that pre-calc stuff, even though we don't like it. But okay, now I'm going to differentiate this in two ways. Now, if you use the Leibniz notation, okay, it likes to say that u equals 2x squared plus 1. Okay, so if you did dy over du, okay, that's doing the derivative of y with respect to u. That would be 20u to the 19. And du over dx, so take the derivative of u, would be 4x. Okay, now this way is not very intuitive, but I just want you to see it. So when you get to university, that's kind of the stuff that gets more confusing to students. They're like, what? Why are they writing it that way? And it's just basically to make it much more complicated. So dy over du equals dy, or over dx, I should say, sorry. Dy over dx equals dy over du times du over dx. So now all you do is substitute. You see, ooh, sorry.
Please
Yep.
excuse the interruption. Could all grade 11 students that are going to be going to see the play this afternoon please make their way downstairs?
Okay. So if you look up above, what is dy over du? It is 20u to the 19. Now what's du over dx? That is 4x. So that would equal, I'm still dy over dx. Okay, that would equal 80x u to the 19. Now if you look up above, what is u? 2x plus 1. So this equals 80x times 2x squared plus 1 to the 19. Yeah? Well, I'm taking the derivative of u, right, with respect to y, and then this is the derivative of u with respect to x. So that means find the inside, the derivative of u. Okay? dy over du is the outside, right? And the inside will be du over dx. Okay? It's just learning the, see, dy over du would be the outside. Du over dx will be the inside. Yeah, but you, well, probably the hardest part about calculus is figuring out all the different guys that, I mean, they come from different countries, they do different things. That's how like this is how it was first done. Okay, and then you can simplify it in your head and go, that's, you know what, you could just do it this way. And it's easy to do it after someone's shown you a specific way. Okay, but they have to do it using certain nomenclature that is universal within the mathematics. So the other way, or use, and this may even look complicated to you, but f of g x, so the derivative f of gx, that's g of x inside of f of x. You do f prime gx times g prime of x. So this is definitely the newest way to be able to write stuff. Okay, so how would you do this one? Well, you had, let's just write it again. Y equals 2x squared plus 1 to the 20. Y prime would equal 20 times 2x squared plus 1 times 4x. Y prime would equal, oops, forgot my 19, would be 80x, 2x plus 1 to the 19. Okay. Okay, so here you can see using Leibniz use there, that's a function within a function. So the first thing is to do dy over du would be 2u. Okay, so I took the derivative of y with respect to u, and then du over dx equals 12x cubed. So I took the derivative of u with respect to x. Okay, now if you can remember, dy over dx equals dy over du times du over dx. So now it's all substitution, because dy over du is 2u times du over dx is 12x cubed. So together it would be, so dy over dx would equal 24u x cubed. Now you look back, oh, what's u? Okay, u is 3x to the 4 x cubed. So our final answer, actually I didn't even do final answer. Oh yeah, 72, oops, 72x to the 7. Now if you can see how this was written up here, there's one thing that said at x equals 1. Okay, so then we would, so dy or dx, x equals 1, all you do is you put in your 72 times 1 to the 7 equals 72. Okay, now here's another one of these that we've been doing pretty well in every one of the rules. It's do the derivatives and then substitute in. Okay, so we're doing f of g of x. What does this equal? F prime of x times g of x, right? Oh, actually, f g of x, sorry, because we know that. But more specifically, we're doing f of g of 3 should equal f prime g of 3 times g of 3, g prime. Well, I'm gonna substitute that now because f of g, yeah, because f prime, this would be, how did I do this? F prime is 6. But you should have the, so this would be f prime of 6 times, see, they should have included that up there. They should have said f prime g of 3 equals 6, but they didn't. G prime of 3 is 5. Okay, I don't know why I'm not doing this. And this would equal 8 times 5, because f, the derivative of f, 6 is 8, and this would equal 40. Does that make sense? Well, this here, and that's why it's kind of, it says right here, oops, g of 3 equals 6, right? So then f prime of 6 equals 8. Okay. So here's definitely a fun question because it is using two laws, right? The first one, chain rule, and what's inside? The quotient rule. Yay. Which one do you first? Always outside in. So y prime would equal 10 times x squared plus 1 over x plus 2 all to the 9 times d over dx x squared plus 1 over x plus 2. Now again, many of you are going to skip that step and probably just do this and actually do the derivative. So we got low is, so we're going to multiply by, this is all going to be in one big set of brackets. Low is x plus 2 times d high is 2x minus high x squared plus 1. I'm still working. X squared plus 1 times, so I'm doing high d low is 1 all over x plus 2 squared. Well, no, because there's an, if this had an x plus 2, does, this one doesn't? Oh yeah, sorry. Okay. Now, this is the same thing as 10 times x squared plus 1 all over x plus 2 to the 9 times, we got 2x squared plus 4x minus 1x squared minus 1 all over x plus 2 squared. Equals 10 times x squared plus 1 over x plus 2 to the 9 times, okay, we can get a bunch of stuff together up top, giving us x squared plus 4x minus 1 all over x plus 2 squared. Well, because I have a 9 out here, I can't. But I can. Okay, so let's go with what you're doing. Now, I would probably accept it here, but if you want to get it, and we always want to think about, well, what if I look at the multiple choice and I still don't have that? This is the same thing as x squared plus 1 to the 9 over x plus 2 to the 9. And then I'll be able to do closer to what you were saying. And that this still x squared plus 4x minus 1 over x plus 2 squared. So now I've kind of got the 9 in there. So really, if you want it to be having lots of fun, why do I have two pluses? I don't know. Times x squared plus 4x minus 1 all over x plus 2 to the 11. You probably can't even look for or wait for the next quiz, hey? Okay. Let's keep on doing. So how do you do it when it's just the function? So there's a function outside of x to the 4. X to the 4 is inside of the function f of x. So this one you would do y prime equals. So we're going to first do the derivative of the outside, which would be f prime, or f derivative, x to the 4. Remember, the stuff inside remains safe. And then you would do the derivative of the inside, which would be 4x to the 3. Now, the only thing that's needs to be done is you should always be putting numbers in the front, and the function should follow. So y prime would equal 4x cubed times f prime of x to the 4. Okay, now b has a mixture of the chain rule that we just learned and the product law from 2 days ago, because we have two things multiplying by each other here. So y prime is the derivative of the first, 3x squared, times the second, fx. Okay, so the derivative of the first times second plus the first times the derivative of the second would be f prime of x squared times 2x. Okay, and we just want to kind of get everything in the right form. This one's nice the way it is, 3x squared f of x squared plus the 2x can come in the front. That would be 2x to the 4 f prime x squared. Okay. Now C is the one I was talking about. You got a function inside of a function inside of a function. And all you have to do is keep things straight and keep working from the outside in until you're done. Okay? So y prime would equal f prime of g of x cubed. Remember, because you don't change the inside when you do the first derivative of the outside. Then times, let's do the derivative of the next level in, g prime of x cubed times 3x squared. Okay, and the only way to finish this up is to put it, so the 3x squared's in the front, times f prime g x cubed times g prime x cubed. So you always want to make sure you keep putting the thing inside. When you do the first derivative, make sure the inside stays in there. With the next derivative, the inside of it, and then, okay. Okay, and then we have the chain rule and the quotient rule. So let's do, just say it's low d high, right? Minus high d low over low squared. So y prime equals, I got low is g of 4x times the derivative of the high would be f prime x squared times 2x. So I did the chain rule right there. Minus the high is f of x squared times derivative of the low. Low is g prime of 4x times 4. And that would all be over g of 4x. And that would be squared. Okay, and again, the only thing now that we want to change is get all the numbers with the variables in the front. So y prime would equal 2x f prime x squared okay. Oh yeah, there it is, g of 4x. Okay, so that's kind of even more in alphabetical order, which I would not penalize for if you had g of 4x before that. Time, and then that's 4 f of x squared g prime of 4x all over g of 4x squared. Yeah, again, you could just go, like I was saying, they were really telling us on the AP exam is get your students to stop here, because if they just said find the derivative and they stopped here, they would get full marks. But if they kept going and they did something wrong. And what I'm trying to say is, but there's still multiple choice on the AP exam. This might be the answer in the multiple choice, or 2 could have been taken out in the multiple choice. So you still have to know how to do it, but if it's written response, kind of stop here. If it was AP exam, not my exam. Yeah, I want to see keep going and make as many mistakes as I make when I do these. That's the fun of being a teacher. Just get everybody back from a day. Okay, so you got the homework there. 102, number 1, 2, 3, 6, A, C, E, K, 7, 9,